Sorry about that, technical difficulties. Welcome again. We are excited to have you join us for the first technical panel on our MSA 2021 online panel discussion series, Iron Furnace Construction. I'm Stacy Holloway, and I am an MSA board member and an online panel committee chair. The Mid-South Sculpture Alliance, MSA, is a nonprofit organization formed in 2006 to advance the creation and awareness of sculpture in its many and varied forms, and to promote a supportive environment for sculpture and sculptors. MSA seeks to advance the understanding that sculpture educates, affects social change, and engages artists, art professionals, and the community in dialogue. Please consider joining us as an MSA member, as there are many opportunities for exhibitions, conference participation, and artist grants and scholarships. This is the fourth panel of our online series, so please follow us on social media to see more about the upcoming panels. All of these panels will be archived on the MSA YouTube channel, Facebook page, and on the MSA website, midsouthsculpture.org, for future access. MSA has been making great strides in its mission to make sculpture accessible with the adoption of new programming, including the online panel series discussion, but also with our current exhibition for MSA professional members, juried by artist and professor Alicia Henry and hosted by the Pam Miller Downtown Arts Center Community Gallery in Lexington, Kentucky. This exhibition is on view weekly on Monday, Wednesday, and Fridays through the month of March, and you can watch a video tour of the exhibition on our website. As well as the New Vision 2020 grant, which was created to support BIPOC artists working in the field of sculpture. Out of a very talented and impressive applicant pool, the winners for this year are Manami Isamora, MacArthur Friedman, and Asa El Sadiq. You can find more information on these artists on our website as well. We are also looking forward to our MSA Interdisciplinary Sculpture Conference hosted by the School of Art, College of Design, Architecture, Art, and Planning at the University of Cincinnati at Pyramid Hill Sculpture Park and Museum. This conference will be packed with panels, presentations, demos, workshops, exhibitions, and a much needed chance to reconnect and re-energize. Please save the date and join us in Cincinnati on October 20th through the 23rd, 2021. This panel will go in depth about iron furnace fabrication and maintenance, and anyone at home who designs and builds a furnace does so at their own risk. With that said, if you are new to iron casting, then we would strongly encourage you to visit, take workshops, and apply for residencies at Metal Arts programs prior to attempting your own furnace, as well as looking at as much reference materials as possible. We will have this list of programs and residencies with our archived videos so that you can look up these for future opportunities. However, an upcoming online conference, the 2021 National Conference on Contemporary Cast Iron Art and Performances, Lived Histories, Imagined Futures, at Sloss Furnaces in Birmingham, Alabama, will be coming up this March 31st through April 3rd, and features Mid-South Sculpture Alliance board member Letitia Bahuyo as the keynote speaker. This conference will have a series of online demonstrations, exhibitions, panels, and presentations, guest furnaces, performances, workshops, and a student cupola contest. Tonight, I will be the voice of the audience during the Q&A portion of this discussion, and if you have any questions, you can comment on the Facebook live video chat, and I will try to get as many of the questions as possible. We may not be able to get to everybody's questions today, but we'll do our best to get back to you via email or Facebook after the event. Iron furnace construction is the fourth of this series and will be our first of more technical panels that will discuss the many different processes and methods used within the field of sculpture. I want to thank all of our panelists for taking the time to share their knowledge, and it is my pleasure to introduce the moderator of this panel, Katelyn Gabbard. Katelyn Gabbard is a graduate of the University of Kentucky where she received her BFA with an emphasis in sculpture and metal casting. During her time in undergrad, she witnessed her first iron pour and fell in love instantly. The newfound love of iron led her to intern with Sculpture Trails Outdoor Museum, and after, she went on to be a foundry apprentice at the National Ornamental Metal Museum in Memphis, Tennessee. She is currently in the MFA program at the University of Louisville, where she is exploring new processes and mediums such as glass to incorporate her art practice. So, welcome, Caitlyn.
Thanks to be here. Thanks. I'm gonna go ahead and share my screen. Get us started. Always a thing. Hold on, you know. Guess we'll do it this way. We looking good? Great. Hello to all. Again, this is the panel discussion on iron furnace construction. Whether you are brand new to the process or well-versed, we hope you can take away some insightful information in preparation for your first or next iron furnace. I'd like to welcome our panelists just by name before we get to the bios. We have Paige Burch, Elizabeth Cronfield, Marjee-Anne Levine, and James Vanderpool. And I'm Katelyn Gabbard. I will be attempting, as you see, to wrangle these people this evening. This will not be easy, but I will try my best, okay? Let's get going. So here we have Paige Burch. He is a lecturer of sculpture and runs the Master Craftsman program at Kennesaw State University. He received his BFA in Studio Art Sculpture from Georgia Southern University in 2007, an MA in Sculpture from SCAD Atlanta in 2009, and an MFA in Sculpture from SCAD Atlanta 2014, because everyone needs 3 degrees in crushing debt. He is trained in foundry, fine woodworking, and metal fabrication. He prefers wooden patterns, cupolettes, botting with a stick, and believes that folks who make IPAs are too lazy to make good beer. He does not have a lot of time to make artwork, but when he does, it is usually pretty asinine. His spirit tool is a 3/4" Stanley Sweetheart 750 socket chisel. I'm going to give you a moment to look through these as we go forward. Next up, we have Elizabeth Cronfield is an artist and educator. She received her BFA from Bowling Green State University in 1996 and her MFA from University of Georgia in 1999. Her work is created primarily out of cast iron mixed with natural materials such as carved stone, porcelain, horsehair, and varies in scale from small pedestal pieces to installations to large outdoor commissions. She has exhibited at numerous spaces worldwide. She is currently Professor of Sculpture and Graduate Director in the School of Art, College of Art and Design at Rochester Institute of Technology in Rochester, New York. Next up, we have Marjee-Anne Levine, is a modern-day alchemist. For 20-plus years, she has sought personal refinement through the practice of working with metals. Margie received her BFA in 2000 from the School of Art Institute of Chicago and her MFA in 2004 from Georgia State University. She is a manager of operations at Sincere Metal Works, a professional fine art bronze casting foundry and custom fabrication shop located in Amesbury, Massachusetts. She is also adjunct professor, foundry and iron casting at Massachusetts College of Art and Design. In 2019, Margie co-founded Eutectic Arts, a 501c3 nonprofit educational and mental health-based organization, using metal casting as an innovative form of learning. She has found both personal conviction and artistic voice through interacting with volatile materials, and together they continue to work in harmony. Next up, James Vanderpool holds his BFA from the University of Kentucky and an MFA in Sculpture from Georgia State University, where he specialized in foundry and woodworking. Originally from Lexington, Kentucky, he returned after grad school to teach studio art at the University of Kentucky and Eastern Kentucky University. James is currently the foundry operations manager at the Metal Museum in Memphis, Tennessee. His personal practice focuses on industrial and functional objects as well as topography. He believes that objects and places hold history and have the ability to tell a story, so he too tries to find that message in his works. He works with cast and or fabricated metal, wood, and schematic drawings in his studio practice. All right, again, welcome panelists. Let's get started, shall we? First up, history. Not only fascinating, but resourceful. I'm gonna go ahead and ask our panel, Biz, Margie, particularly, what does our history look like?
Okay, I'll go. So before the 1960s in the States, there weren't a lot of sculptors using cast iron as a medium. Julius Schmidt, who is dubbed the grandfather of iron, was one of the first artists to be drawn to the material. And in order to produce his work, he had to bring his molds to an industrial iron foundry to get poured. He wasn't too pleased with having to rely on others, so he was one of the first people to scale down that equipment and make it accessible at our scale for artists. That was at Cranbrook Academy of Art, and a lot of the tendrils of the iron community spread from there. So there were a few disciples of Julius's that also built, adapted and built furnaces at a smaller scale, and those were spread sort of across the country through, through collaborative pours, conferences, word of mouth, exchanging of sketches, etc. So the few photos that we have here show some of the earliest cupolas that a lot were then copied very frequently throughout the country. And I had to throw that Koopalette in there too, because Cliff would be mad at me otherwise.
Hey, do we have anything additional you guys want to add? Any experiences with some of the imagery that we're seeing?
Just to piggyback on what Margie's saying, I think that things got far more widespread with the advance of the conferences, right? And so in the late 80s and throughout the 90s, that information that was held by a dozen or so individuals just started exploding into dozens and dozens and dozens that are now out there and teaching the process.
Okay, so essentially, what are we all talking about? We're talking about a tool, and specifically with this panel, we're talking about the construction of a tool. So generally, overall, this is always a good debate. Cupola versus Koopalette. Go.
Okay, I think before we start that fight page, let's talk about the sections of the furnace before the top, right? Which is what this schematic is showing us, right? So regardless of the furnace and regardless of the size and what you put on top, making it determining whether it's a cupola or a Koopalette, you've got the bottom section, which is the well, which is called that because that's where the iron wells up and collects before you take it out. You have the melt zone, which is the middle of the furnace at the tweers where the air is coming in to heat up the coke to melt the iron. So that's the middle of the furnace. And then you have a choice at the top, right? And that's where the fight begins. So if you build a traditional cupola, you put a tall stack on that cupola so that you can stack up charges of little cokes and iron, coke iron, all the way up, right? And that not only gives you your metal to melt, but it also provides the back pressure to keep that blast inside the furnace. Your alternative, if you make the wrong decision, is to build what's called a Koopalette, where you shorten that stack you basically leave room for one charge of coke and iron, and then you put a lid on the top. So that provides your back pressure as opposed to those multiple charges going all the way up the stack. There are pros and cons to both, and we can fight that out as the night goes on. Okay.
Yeah, you know, I just like making life a lot easier on myself. So call me lazy, totally fine.
So if you are looking at the fundamental of what a furnace is, right? That's what these diagrams are showing you. It's showing you the parts of the furnace, right? Not the sections, but how the furnace is actually constructed. So 99.9 times out of 10, that's good. Out of 100, you have a metal shell, right? You have a steel or stainless shell, although that's not a necessity. You have some form of refractory lining, right? That hard refractory concrete looking stuff. You may or may not have a wind belt. This drawing actually pigeonholes that one. But you need a place where air can enter the furnace, and that's what we're referring to as a tweer or multiple tweers, okay? You have a tap hole, you have a slag hole to drain off the impurities that float, and I think that's all that's in this drawing. And it's sitting on some kind of table or legs, okay?
Paige, do you want to elaborate a little bit?
Hey, do you want to start it off there?
Yeah, I mean, you know, like Margie was saying, you know, they're basic, you know, universal principles in the furnace, and everything else is really customizable. And that's one of the really cool things about this. You can literally tailor it however you want. That's one of the most interesting things to me about furnaces is you've seen some really gorgeous furnaces. You've seen some just like hot trash looking furnaces that run really well, and you can make them work for whatever you need them to work for. And so yeah, you know, that's one of the beautiful things about it. And you know, when I was asked to start, you know, the iron program at KSU, they wanted us to copy the Georgia State Cupola, and you know, it's a 300-pound furnace, and you know, it's big, 16-inch diameter, 4-inch refractory. You know, all my students at the time were basically a bunch of 5'2" girls, and it's like, they've never cast iron before. We don't need anything like that. So, you know, just made a little smaller furnace, which was ideal for us. And, you know, it has been ideal for us in the, you know, the 10 years we've been doing it. I love the fact that you can make a furnace that will literally spit out 1 drop of molten iron, or you can make one that, you know, drops 5,000 pounds at a time. And so that's to me what really is exciting about furnaces. And the, you know, our everyday furnace at Kennesaw State, I've made it where you can run it as a cupola, or you can run it as a Koopalette. I prefer Coopolettes, again, like I said, because I guess I just don't like to work hard. That's fine. That's fair enough. But you know, when I'm teaching people how to do it, it's a lot easier to teach because it's not going to run quite as fast. And so if we ever have to, you know, really boogie, we can just roll up, you know, throw the stack on it, run as a cupola. And so just, again, having all those options is really nice. You know, you can go for speed or comfort.
So
I guess it's the southerner in me that likes the slowness, and it's just, you know, the northerner in you that just likes that speed and get it done.
Yeah, Bostonian, just get it over with. But let's explain to people why a Koopalette runs slower and more controlled than a cupola, because I think that's important, right? So if you look at this diagram and refer back to what we were saying, where if you put a stack on a cupola, you're loading up, I load up 3 charges, coke iron, coke iron, coke iron, okay? Which means that while charge number 1 is melting, charges number 2 and 3 are preheating. So by the time they drop and get to that melt zone, and they're already ready to melt, which is speeding up the overall melt time, okay? Versus a Koopalette, you are putting in 1 charge at a time, so it's a slower melt. Where we're saying, you know, we all like to pick on each other, and I'll defend cupolas all day long because You're saying that Koopalettes are easier, which I agree they are, but they take twice as long, and I'm getting older and fatter, and I don't want to stand on that pour field for longer than I need to. Okay, but if I had a smaller crew or smaller molds, or I was using it as a teaching opportunity, then I absolutely see the advantage of a Koopalette. The other thing that's nice about a Koopalette, because of that lid, is that you can stop charging, right? So if you have a cupola and you're relying on those charges, coke iron, to provide the back pressure for the furnace itself, because it has no lid, you can never stop charging, right? You can't slow that furnace down. There's a couple ways you can slow the furnace down, but you can't just stop, right? With a Koopalette, you totally can, right? You can just stop charging because that lid will keep the heat in. You might eat up a little bit of bed coke, gotta be careful, but so, you know, so there are pros and cons in both ways. Katie, I think our next slide is the side-by-side convertible, right? Yeah. So here's exactly what Paige is talking about. This is one of our furnaces at MassArt, and hopefully you can see that the bottom, you know, 3/4 of it is the same furnace, and then either you put that extended stack on or you put the lid on. To give you an example of what we're talking about, this furnace will tap 100 pounds of metal. If I run it as a cupola, it will tap 100 pounds of metal every 6 or 7 minutes. If I run it as a Koopalette, it's going to be more like 15-ish minutes, right? And that makes a really big difference depending on the crew that you have at your disposal.
Yeah, we don't all have armies like you do up there.
Fair enough.
Well, piggybacking on what Paige was talking about as well, the idea, like when we were looking at our furnace for the museum, you know, I was kind of the same as Paige when he was asked to look at Georgia State's. You know, that's kind of the first one that I ran, was the 16-inch Koopalette, and it was great for me because I had never run one on my own before, and it was an easy learner, because, you know, you're looking straight at the melt zone. You can tell exactly what it's doing, you know, when it's doing it. If you're doing things like tweaking your air pressure, if you're a first timer, things like that. Also, you know, for the most part, unless we're doing a big pour at our conference or something like that, we're running with a smaller crew, usually not a lot of metal. So, you know, having the ability to run a little bit slower so you're not exhausting your crew was advantageous for me. And the idea that even though it's running a little bit slower, we're still getting a lot of hot metal. And the other thing that I was thinking about as you were talking, Margie, about the difference between, you know, preheating your charges as you're coming down on a cupola versus the Koopalette. You know, every single time you charge, you're opening that lid and you are losing heat. So you have to go quick with it. But as far as teaching people, you know, we're teaching apprentices and we're doing smaller pours where, you know, maybe we only need 300-400 pounds of metal. A little bit longer is okay with me if I can kind of save the stress of running back-to-back pour crews and things like that. You know, with the 16-inch method, that the designs that I got were George Beasley, Prokop, and Wayne, were who was attributed on the designs I got. You know, with that 16-inch furnace, we can do up to 300 pounds. So that's, at the moment, I don't want to do more than that because I don't have a crane to carry it on. And if I'm going to have crews carrying it on their backs, then, you know, we can't really do more than that. So a little bit slower kind of worked for us in our situation. But yeah, no, I totally understand what you're talking about, Margie. You know, if you have a ton of molds and you have a big crew, get it done, get out of there. But Paige, I totally understand the Southerner in you. Let's slow it down a little bit, but you know.
I do think it's worth pointing out, because now it's Paige and James that have both referenced the Georgia State Cupola, which I'm really familiar with as well. That's the furnace I ran when I was there. Biz, I know you know that furnace too. That tells you everything you need to know about the history of iron casting lineage, right? The fact that all of us have some connection to Georgia State, which is George Beasley, which goes back to Julius, which is not the only route you can take to get where we are by any means, but it is a testament to what George built at Georgia State. So I got to give George a shout out.
And my two furnaces, my little two 14-inch Cupalettes, they're based off of designs from Tom Geip and Edwardsville, SIU Edwardsville. And so again, it follows that same kind of tree of, sort of like the 3 or 4 or 5, kind of like godfathers of the iron casting that we've all indirectly learned from. And so all this stuff, it's rooted in history, and that's why it shouldn't be that difficult to make work.
Yeah, not much has changed.
Yeah.
Biz, did you have any more you wanted to add to that before we get on with some logistics?
Well, this might even lead into what you're trying to talk about, but I think James made a great point on the fact that, you can build these things any size, and there will be people that argue different sizes are better, but, you're building it to fit your needs. And there are needs for very large furnaces, and there are needs for very small furnaces. And so, figuring out what your needs are first, I think is the very first step as far as design.
I totally agree with that. And not only needs, but also resources, right? Do you have a forklift, right? Do you have a permanent place to store your furnace outside? I do not, right? Our furnaces get brought in and out every time we use them with no ramp. So assessing not only need, but also, what you have access to. Do you have a crane, right? How many people do you have goes back to that same, style of furnace. So hopefully we're going to start to answer some of those questions here as we move further along and show you different types and styles and choices. Okay. But since this slide is up, this is one of my favorite slides. Okay. When I start talking about furnaces with anybody, especially new, my statement is an iron furnace is a cylinder with 3 holes. That's it. That's all it has to be. As long as those 3 holes are in the right place in relationship to the diameter and to each other, it will function. It can get way crazier than that, right? You can build it out of all sorts of funky stuff and make it decorative and change the size and add more holes if you want. But if those 3 holes are right, you're going to have a working furnace. Okay. So if we look at how you determine where those 3 holes need to be, okay, your 3 holes are your tap hole, where you're taking metal out, your slag hole, which is draining off the impurities that float on top of the metal, but it also is determining the capacity of your well, right? Because nothing wants to go past that slag hole where stuff is draining out. And then you have at least 1 tweer. That's the 3rd hole. You can have multiple tweers, which is where you can have multiple holes, okay? You can also have multiple slag holes. We'll get there in a minute. So rule number 1, don't break this one. Your well should never be taller than it is wide, okay? Furnaces should look like me, right? Short and fat, not tall and skinny, okay? The reason for this is that all of you have coke burning inside your furnace, but the hottest part of your furnace is up in that melt zone. And then heat, of course, is going up, right? No heat is actually going down towards the tap hole. So if you have a really tall, skinny well, that tap hole is always going to want to get cold, right? So short and fat keeps the heat down there better. Okay, rule number 1.
Yeah, I think it's really important to remember too that, a lot of people just assume that the bottom is the hottest part and where the liquid metal is, and it's not, and if that gets cold, then you have problems.
Yes. Okay, so when you're determining the size of the furnace that you're going to build, you know, a really common question is, how much metal do I want to tap at a time? How much metal do I want to take out at any given tap, right? And that goes back to what Biz was talking about. So you can calculate that volume, okay, volume of a cylinder, and that's from the bottom of your tap hole to the bottom of your slag hole is the volume of your well inside the refractory. So all of these numbers are inside diameter, right, inside your refractory. You also, when you're doing that calculation, you have to take into account that the coke, the bed coke that you're putting in there, is going to take up 60% of your well capacity. So once you figure out the overall volume, you have to multiply that by 40% to find out the actual volume, okay? Iron weighs 0.26 pounds per cubic inch, so you can actually find that out in poundage, which is kind of a nice thing to know. I'm always a little shocked when people don't know what their well holds, because then how do you like pick a ladle that matches that, which would be a good thing to have, maybe, okay? We can revisit any of this if I'm going too fast. The last thing, so that's holes number 1 and 2, okay? Hole number 3 is your tweer, where the air is entering the furnace. I always challenge the students to memorize this formula, but it's so not necessary, okay? So the calculation for your tweers is 0.7854 times ID squared divided by 8. Gives you the area of your tweer. And people always mess this one up and say, oh, I got an area of, 5, so I'm gonna have a 5-inch tweer. Area does not equal inches, okay? So you have to convert from area to find your radius, okay? If you're doing multiple tweers, you find the total area, you divide that by the number of tweers you want, and then you can find your radius per tweer. We should have a conversation, I think, about single tweer versus double versus wind belt would be an interesting discussion, because I get asked that question a lot, and I've talked a lot, so one of you should say something.
We do need to go in, if you guys want to talk about the slag holes, we do need to go into that and move forward a bit.
All right, should we do slag holes instead of tweers? Okay.
Sure, yeah.
Let's move on to slag holes.
And a lot of this information for everybody out there, a lot of this information will be provided that you can go back and reference along with this panel, that you can also go back and reference. These are like little freebie diagrams. Take them. They are amazing. Continue on, you all. So single versus dual.
Well,
First, I want to just point out the importance of a slag hole. I mean, what does it do? When I first went to one institution that I taught at, there was a furnace there without a slag hole. So I think that first thing is, somebody else can jump in if you want to, but let's talk about the importance of the slag hole.
Yeah, I mean, it's going to get most of the impurities out of your furnace. If you're running a furnace without a slag hole, once you tap, you're just gunking the inside of your furnace up, and then you're eventually just shrinking your well down. You have to go back in after the pour, clean that out. So yeah, it's really important to have one. And I think you're doing yourself a disservice if you don't have more than one. I mean, you want to have options. And so, it's easy to bot one up if you're not using it right then. But yeah, having multiples is great.
Well, one thing that I ran into initially when we built our furnace, which I don't know why I didn't even think about, is, the slag hole is running your impurities off. Your impurities are much thicker than the liquid iron. So making sure you're not giving a little dime size, slag hole that's going to clog up over and over and over on you, making it a size where, those impurities are going to come off really nicely without you having to poke into it too much and, freeze that little portion, because every time you're poking into that slag hole, you're introducing a cooler tool into that area, so it has the potential to cool down a little bit. But yeah, what Paige was saying, I agree with. When we were looking at ours, I knew that the fiber ladle people I talked to have 150 pound capacity fiber ladle, and they have a 300. So, our furnace does about 125, and then the top tweer does about 225, and then very carefully, if you're timing it and you know exactly how you're melting, you can even bot that top tweer to get a little bit more, 300 pounds. Now the danger in that is that if you do bot your top tweer and you're running it up higher, if that metal goes into your wind belt, game over. So you have to really, really, really be careful about that.
That's the other really important function of a slag hole, right? Is to act as your timekeeper, right? That you never, unless you bought it intentionally, which I've done, but that's risky business, right? That it will always prevent the metal from going up where no metal should go. Okay.
It's like a little top drain hole in your sink. It's never going to go over the top.
Yeah.
And I think James brought up a good point about when you're tending to the slag hole, about not, just like jamming the tool in there. You should never really have to put your tool in your slagger at all. You should just kind of keep it around the edge whenever you're doing it. And, if you have to help it out, but don't just start, shoving it in there, and, you can disturb your bed cope like that. There are a lot of things that they can do wrong by doing that.
It's also worth mentioning, because James just brought this up. So if you're using fiber ladles, so this is our big furnace at MassArt. The top slag hole is 300 pounds, right? I have no crane, I have no forklift, I have teeny tiny people. But if you're using fiber ladles, I can get 300 pounds out, hold it, and get another 300 pounds out. So I can pour a 600 pound mold with not a gigantic furnace and not, a big bowl ladle on a gantry, right? With 4 ladle teams on 150 pound ladles. So, so there are ways to accommodate larger molds, even if you don't have, huge equipment.
You all, we talked a little bit about the tweers before. While we're on this imagery right here, do you want to just wrap up a little bit of information on the tweers?
Well, that's my favorite style of tweer. Tweer with glass, so you don't have to open it up to just look in the furnace.
And play hot potato with the black
and
pipe.
cross thread when you screw it back on. Actually, I like one step a little bit beyond just the glass. On the inside, I like to use a scientific watch glass that's high temp, and then on the outside, put shade 5 goggle lens on it, so you don't even need glasses to look in the thing. So you can see what it's doing without having to open the tweer up, which will disturb your wind pressure.
So these are all borosilicate high temp glass, and I have one that's a cobalt. It's cobalt borosilicate, so you can see it's beautiful. Yeah.
Nice.
Yeah.
A question for you.
I was to say, George introduced me to the cobalt. When I tried to find some, I realized that I'm poor.
It's super expensive. My students know that they better not break that one.
Yeah.
If you want a little bit cheaper, but you're gonna break it because it's not high temp, just those welding shade 5 lenses. They're cheaper, but you're gonna go through them.
So with all of that as well, and we all know how easy it is to break that very lovely glass when you're going to poke the tweers. So what is it that is happening when you go to poke the tweers?
Okay, first of all, treat her like a lady. That's all I'm saying. Okay? There's no reason. So, especially new iron casters love having something to do. This is why it's a problem to run a Koopalette, because everyone wants something to do, and then they start poking at shit that they shouldn't poke at. So poking the tweers means that sometimes you get like stalactites coming down over your tweer opening. And if that got completely gunked up, it would block your air from going through your tweer, which you need the air. Okay. Now if there's like a 1/4 inch bare, halfway down my tweer, it does not need to get poked. Right. So I sit there and go, do you like this? Do you want to get poked all the time? Right? How do you feel about this? Now, when it's like half sealed over, that's when you open the tweer and poke it. And you should never open more than one at a time because you lose your pressure.
Yeah, and you have to be really careful when you're doing this, because the whole point of the tweezers is to get air into your furnace. And so, you know, a little bit isn't gonna, you know, it's not gonna affect the performance. So like you said, you know, it has to be a lot. And where I come from, we don't poke tweezers, we tweedle the tweezers.
Oh,
It's a pinky up thing.
Thanks. Does somebody want to read this lovely quote? You all are blocking it for me, so that would be lovely if somebody could do that.
I think we're blocking it for
Warhol
each other.
wrote, what? Wherever work is so elementally transformative, workers' implements are ensouled. Next.
This is like a simple versus complex, going back to some of the design. You guys want to talk any about these images?
Going back to that previous image, I'm always remembered. I had got to, I went to Georgia State and never ran a furnace by myself. And I got there the year George Beasley retired. And so I'm freaking out because I went there to do iron. And the very first time that I loaded up that furnace myself and, started getting it ready before everyone got there, I'm freaking out. And I'll never forget George, kind of off the cuff, told me, man, it's not rocket science. This technology has been around for thousands and thousands of years. It's a trash can that we fill with mud, put 3 holes in, and throw fire at. As long as the holes are in the, like what Margie was saying, as long as the holes are in the right place and the blower's doing what it should, it's gonna work. Like, stop, it's not as mystical as you're thinking it is. And I think that image of Butch Jack just sums it up right there.
Yeah, and I remember the first time I saw Butch in a trash can furnace was at Iron Bridge in 2006, and I was still pretty new to casting at that point, and it floored me because I was just like, wait, what? And it was just, it really hit home. There's like, wow, these things, yeah, this is pretty simple actually. You literally can make anything work if you pay attention to it, and that was great for me.
And I think this goes back to designing what is best for you. And part of that, like we were talking about, is size, right? And the ability that you have for help and assistance, but it's also budget. And there's so many things that are just dependent on the budget that you have. And one of the things that we've not talked about is we've talked about refractory and lining, and that's it. And it's so vital to building a furnace is knowing your types of refractory, because there are lots of types that will work. There are several types that will work way better than others, but you should really know like the alumina content of your refractory. You should know the difference between an insulatory or a hard refractory or reflective refractory. You need to know what low cement means. There's a lot of just different variables in that refractory, and people just say, oh, castable or rammable, but there's those come in so many varieties. So understanding refractory is a really big thing. And you can make a refractory out of fire clay and sand if your budget is low. If your budget is medium or kind of lowish medium, you can get glass patch. If you have a decent budget, then go for a 70% alumina castable. So there's so many kind of varieties in there.
And that's great. So this next little bit is all about the tools that are used, the essentials. So I'm going to go through some of these pictures if you guys want to start talking about what you're seeing.
Well, this one is pretty funny because it's about, matching your tools to your tools. So if you look at the size of the cupola to the size of the blower, I had to run this one time with Matt, and that's the blower that we were told to use with that furnace.
Outstanding. Yeah, I mean, and going back to that, the tools are super important because if you don't make your tools right, or if you buy the wrong tools, you're not going to have a good time. And, it goes back even, to the blowers. If you're trying to use a squirrel cage on a burn-in torch to burn in like a 20-inch furnace, you're not gonna do a lot with it. So, making sure that you understand the tools, what they do, and making sure that, you have blowers that are big enough so that you don't try to run a furnace without enough, power. Those are all like really important things that probably get overlooked. Because a lot of people just say, oh, so-and-so has this blower, I'll use that one. But, there's a science and math behind how much air is optimal to go into the furnace. And so I think it's really important that people, sit down and try to learn that and understand that.
I think that it also provides you an opportunity to customize based on your personal needs or the needs of the demographic that you're pouring with, right? Which is, this is what my entire career has been, is making sure that my 5 foot tall stature can do all this. I got sick of running furnaces that I couldn't see into and using ladles that I couldn't lift, and I was hurting my back. And so I just said, I'm going to start designing and making my own stuff, right? Things that fit perfectly in the bed of my pickup truck and break down into pieces so I can carry them. And a specially designed step for those of us who are, vertically impaired. This slide that's up is a great example of, my breakdown ladle shanks, right? Because I got really sick of having to pack 7 foot long ladles. So I just made the arms of the ladle bolt on and off, basically. And I hope that you guys all will invest in some fiber ladles. No one should ever be using refractory ladles anymore unless you have a gantry.
I mean, piggybacking on that, just the very end of what you were talking about, how much money have we been spending in propane to warm the refractory fiber ladles? It warrants, a $20, $25 fiber ladle.
Yeah.
And saving your crew's back is another thing.
Well, and also the ladles are cheaper than the gas.
Oh yeah.
So coming out ahead.
One thing that I have found since we're on this image too, talking with some of the fiber ladle people, and also going back to talking about what Biz was saying about refractory. For those of you that are maybe newer or you don't have someone you can immediately reach out to, asking questions about either refractory or your fiber ladles, talk to your local refractory supplier. They know what their product will handle. They know the temperatures straight up let them know what you're doing with it, because they know their business. They know what their product can handle. But with the fiber ladles, what I've found with those is right at the very bottom of the fiber ladle in that little corner is where they always want to break out. And I was talking to one of the fiber ladle people. He said, just build a rim around the bottom, put a layer of sand down, put your fiber ladle in, fill a little bit of sand up in that little rim, and then put either a refractory or sometimes we'll use bot on top of that. And 9 times out of 10, it breaks out at that little corner. But if you put that little gasket, and I wouldn't have known that if I didn't call the guy. So, call your suppliers, get to know them, because it's really important. Jumping on also what Margie was saying about making your tools do what you need them to do. Making your tools do what you need them to do. I think as you're starting to think about your furnace and how it goes together, that's an excellent time to start thinking about things like Margie was saying. Is it going to have to travel a lot? Is it going to have to come apart? And, coming apart isn't just for travel. It's also for ease of maintenance. Your refractory is going to fail at some point. You will need to reline this furnace. Make it as easy on yourself as you can. Tattletale on myself. Katie helped me build the museum's furnace, and we made sure everything bolted together. It came off that bottom table. We painstakingly, everything comes apart. We have lift points for the well and stack. We have lift points for the table, and then I got sidetracked and welded my tap spout to the table. That's really hard to get a grinder in. I don't know why I did that, but even when you're starting to design your furnace, think how the furnace attaches to your table. Think how you're going to lift it. If you have a forklift, put a forklift spot in it. Put some channeling. Make it easy on yourself.
The other thing about maintenance, when speaking about relining in sections, not only is it physically easier to reline your furnace if it comes apart in lots of sections, but it also means that you don't have to reline the whole thing every time, right? It's your melt zone and your well that are going to deteriorate long before your stack. I think the lining on my stack is original, right? I don't think I've ever relined it because there's not as much corrosive activity going on up there and there's not as much heat. So, so that way you can literally, if you make your furnace break apart in those sections specifically, you can say, okay, my melt zone has really bellied out, time to reline that section only. So you're saving on refractory labor and cost, which is really great.
Yeah.
Do you guys just want to kind of touch on, not all of our guests tonight are going to understand this perhaps at this point. In the future, yes. So do you guys just want to touch on this little funny, controversial debate here? Paige, it's literally in your bio, so maybe you should go first.
Okay, I'll put that in there just to be a jackass. But yeah, no, I mean, a bot stick is a tool that is gonna, save you from potentially burning your hand. And if it's made right, if your bot's made right, it's really simple to use. And if not, then yeah, you get to play the put your hand on the stream of iron game. And anybody who runs a furnace knows that your gloves, you get that cool furnace pinky going, and they get their, a lot of wear and tear on them. There've been holes. I hand botted one time, had a hole in one of my gloves. A little bit got up in there, and it wasn't pleasant. So it's. I'm not going to chastise anybody for not, but I would highly recommend doing it.
So I feel like it's important to point out what a bot is, right? For those who don't know, a bot is the clay plug that seals up your tap hole in between taps, right? So you tap, you take all the metal out of your well, and then you bot that hole so that the next well full can start accumulating, okay? So when we're talking about botting or bot sticks, we're talking about how you squish that clay plug into that hole, okay? And the controversy is to use a bot stick or not to use a bot stick. I am pro bot stick. I believe that if I make a gasket, I make like a slip and sand glue, and you dunk your bot stick in that and then suction your bot on, and it stays there, and it's no big deal. And I'm just not cool enough to shove my hands right in a stream of iron, unless I'm skimming with my finger, which I do frequently.
Real quick, I would also, bot sticks are wonderful things if you make them right. But going back to design real quick, I think that when you're designing your furnace, design it so that you're not having to bot midstream, meaning that you have more iron in your well than your ladle will hold. So that's kind of the first step of the process. How much is in my well? How much will my ladle hold? Make those two match up first and foremost, because the biggest problem I see with hand botting is that you're hand botting a stream of metal, which could really damage your hand. And as makers, we love our hands. But also it could throw that bot back page into the...
I was just about to bring that up.
Or into the ladle, yeah.
Yeah, you want to make sure that, like I said before, you make the bot properly and the bot stick's done properly, because the last thing you want is to be pouring in front of a group of people at Sloss and then have your bot trickle down your spout and fall into the ladle, and that's a real cool guy feeling. So don't be like me.
Yeah, and if the bot falls out and rolls into your ladle, you do not take your wet bot stick and try to fish it out of the ladle and cause a steam explosion.
No, you run around one side of the furnace and let the other guy run around the other side of the furnace, and then you meet in the back and rebot it.
Mm-hmm.
Well, I think I accidentally skipped over this lovely picture, but we were talking to you about the skimmers, another tool. This is going back to impurities, so
The only thing I will say is it's a skimmer, not a dunker.
Ooh.
That's a good one.
Yeah.
Yeah, the skimmer is by far the most important person on a pour team, right? They're the ones that are going to make sure that no junk gets in your mold. The only thing I have to say about this image is that the tools on the right hand side, I made very specifically. I put those twists in for grip, for traction, but it also tells my students exactly where to put their hands, right? So it makes them really comfortable that they understand how to hold the tool and can feel it properly in their hands. So that's just a tactile thing.
Going back to people that maybe have not used fiber ladles, a big difference between a traditional refractory ladle and a fiber ladle when you're skimming is to not scrape. Do not use that skimmer to scrape the sides. That fiber ladle is fragile. But one of the nice things about the skull that develops on a fiber ladle is usually if your metal is hot enough, the next tap will take care of it. One thing we also did at Georgia State, which I have not done yet at the museum, but I've always threatened to, is after the initial skim, George had us at Georgia State use a pushback, which looks exactly like that metal skimmer, except the very end of it is a lag screw, and you screw a wooden paddle onto the end. So what you're doing is, as the metal's pouring into the mold and you're trying to hold back the little bit of slag that's still in your ladle, you can push it back with a piece of wood instead of metal, which won't chill your pot.
Early days of Sloss, we just used a 1x.
2x4.
There were no fancy tools. It was
Yeah.
called a 1x, was your pushback.
Yeah, I've definitely skimmed with a 2x4.
Yep.
all right. And so now we're on the 7 deadly sins of the furnace. This is kind of when it all comes together, and the good, the bad, and the ugly. So have at it, you all.
I'm gonna start with one because we talked a little bit about multiple slaggers, but we didn't talk about the design of multiple slaggers. And the largest furnace that I ever ran had multiple slaggers that were lined up, and this was for a very, very, very large pour. And the furnace was holding tons of metal, and they were lined up all in a row, like drill holes in a stone when you would go to split a stone, and there was no metal sleeve in between those holes. And during burn-in, we watched the craft in the refractory grow in between those slag holes, and it was a pour that we had to go on with. We couldn't just stop and bag it. This was a very, very big thing that happened. So just that's something that I think is a deadly sin in design. So keep that in mind.
Yeah, and going back to that, like one of the first pours I ever did, we were doing a performance and we built the furnace specifically for that. Well, we didn't really have enough refractory for it, so we had a super thin liner, like maybe 1.5 inches, if even that. And so, this was on top of a big platform and we're burning in, and I looked up and I started seeing all these little red spots. Well, where we had welded in hangers, it was starting to burn through into burning already. And so we just had to, get up on this kind of crow's nest platform and, just kind of start wiping it down and hoping that it didn't burn through. So making sure that you have, enough material to adequately, prepare for your pour is really important as well.
Because we have the picture of that shit show is in here somewhere. You can get away. You can get away with a lot, right? Like glowing steel shell because of bad refractory. Okay, I definitely have charged coke, iron, water repeatedly on George's furnaces, but that's because they're made of sticks. But it, you know, coke, iron, dump water down the side. We built, at one point, we built 5 furnaces in 5 days. We lined them with, I'm not joking, 3/4 of an inch of homemade refractory. There's the shit show. So, you know, that's a single-use furnace, right? Do you want a production furnace? Do you want a single-use furnace? Is it a performance? Right? Those all come down to intent.
I'm going to echo that, and I think I've said this a few times tonight. Just make the tool what you want it to be, what you need it to be. You know, and obviously safety should be the first thing in mind. The safety of your crew, right? If you have a small crew that is inexperienced, you shouldn't be building a huge furnace. Or if you have a gantry and you have 3 experienced people and a bunch of inexperienced people, maybe you should build a huge furnace so that there are just 3 people running it, and you're using all overhead lifting devices, you know? So there's really just so many different variables. There's not a right furnace for everybody. There is not a right method for everybody. And I have built very few furnaces. I have run an insane amount of furnaces that are all different kinds of designs, and I show up and have to run them. And you know what? They almost all run. So just figuring out like what works best for you.
And a lot of times if it doesn't run, then you can break down what happened and you can tweak it and get it to run. We just saw the exquisite cupola a couple of slides back. I was one of the people who helped put that together at the Scottish Sculpture Workshop, and we ran it at Iron Bridge. And like the name implied, the iron bridged. And yeah, it just, you know, they ran it again in Wales a few years later, and they got it to work. So just because it doesn't work the first time doesn't mean that, you know, it's lost. You can fix things or tweak things, and you can make it work.
We barely got it to run in Wales. Barely.
We did.
I got iron out because George told me that I damn well better. So,
Well, there you go.
and you don't let the man down.
Oh, yeah. I think one of, especially with first-time furnace builders, for me at least, the hardest thing to tweak with what went wrong has always been air pressure. Do I need more? Do I need less? And when did it actually go wrong?
That's what I was talking about. Sorry.
Oh yeah. But actually, that's a great image for what I was about to say. Was when you're building a furnace, especially if you think you're going to have a crew of 5, 6, 8, 10 people, it's easy to forget because you're going to be around the tap hole tweers and slaggers that there are people walking up and down charging this thing. Be kind to your chargers. Make sure that they have a good path to the furnace and away from the furnace. Make sure that they have an easy way to get the charges up to where they need to be. It as far as just ease for your crew. And I saw the one stick furnace back there with just the little step ladder. When I built a furnace, a stick furnace with George, I had this weird ramp going up because I was just like, dude, I can't climb that all day.
Yeah.
So yeah, be kind to your chargers. Make sure that they have a safe way to get up and down. That's one of the biggest things that I found with furnace design is, you're going to be chucking heavy stuff up high all day long. So
I think that the biggest thing
folks out there, I'm sorry, Margie, just for folks out there, obviously, some of these images are very highly performative pieces as well. So when we're talking a little bit about this, it's mainly for some of the more traditional furnaces you've seen.
But I think that that's sort of the point that I wanted to make is that for me, what I hear most commonly is sort of a lack of confidence. Like, oh, I wouldn't know how to build a furnace, right? Or I wouldn't know what to do or what I want, whatever. I built my first furnace never having seen an iron core. Okay, if I can do it, then anybody can do it. And even though right now we're looking at these, awesome, showy, crazy pictures, right? It's still just that cylinder with 3 holes in it. It's that easy. And it can be a performance, right? And it can be this, beautiful ornate sculpture in and of itself, or it can be a trash can with some refractory to melt some metal to get it in your mold safely, right? That's the bottom line of what a furnace should be. So, Biz keeps harping on this, right? Figure out what you need and what you want. And then there are so many people like us out in the world that would gladly help you figure it out.
Yeah, and that's one of the important things is to make sure that you talk, not even just to one person, but talk to a bunch of different people, because you're going to get a lot of different perspectives like that. Otherwise you're just going to end up, making what someone else wants you to make and not what you necessarily want or need. So, like Margie said, we love talking about this. I'll talk about building furnaces all day with people. And so, yeah, just reach out to different people.
Okay, I think we do need to wrap up. We are a little over, but Stacy, feel free to jump in here in a second. I'm gonna run through. We have some of these slides up. I would just like to share. Does anyone want to kind of just go over student cupola really quick before I run through these?
I think the pertinent information here is that student cupola is a competition as part of the national conference at SLOS. It has to be student built, student run, all 10-inch inside diameter. And I think what's interesting to note is the diversity of solutions that the students come up with, right? They're all the same furnace. It's a 10-inch ID, but look at how different they all come out. And that's really all that needs to be said. And kudos to the students for stepping up and putting on a good show every 2 years.
And if you are a student building a furnace for the contest, make your damn tap hole big enough.
Wish everybody a lot of luck with all of that, and we shall be together soon. Stacy, we're ready for you.
So Miranda Kyle did ask a while ago, did any of these original Cranbrook furnaces survive?
Yeah, one's at SLOS.
Yeah, the whiting is at SLOS, right, Biz?
Yeah, they ran it last conference.
I'm not sure it's online anymore. Stacy, you probably know. I think it's been offline for a while.
I don't think they've used it that much.
No, they ran it last SLOS.
Yeah.
Yeah.
Is that the whitey? Okay,
They
I get
ran
that
both
one
of
and the
them.
other big one mixed up.
Yeah, they ran Timmy and the Whiting side by side.
Yeah.
Right.
I know they took it offline for several years, so I'm glad they brought it back.
So there was Carl Weston asked so that I've only had experience working with bronze and aluminum. So as a material, what benefits does iron provide? And there were a lot of people. You have a little support group going on in the Facebook chat where Kristen Tordell Williams and Ed Paradise, they all kind of chimed in, but I think it might be good for them to hear from you too.
For me, it was very much about aesthetics. When I was in undergrad, I was only around a non-ferrous foundry, and I had no desire to cast. I was a stone carver, and I fabricated steel. And then when I went to grad school, I went to University of Georgia, and my husband, Matt Ricker, went to Georgia State, and so I was introduced to cast iron. And all of a sudden, I was able to get the look of steel with the forms that I wanted to create, that I could not do, or at least not easily, through fabrication. So for me, it was an aesthetic decision.
I just really like how easy it is to weld. But no, I mean, really, it boils down to, like Biz said, the aesthetics of it to me are really pleasing, but also the availability of it. It's not, it's not a really high material. It's a really kind of like every man's material. It's an industrial material, and that speaks to me because the material, is as important as the process, and so it's a whole different process, and so that's why I was drawn to iron, as a material.
I think for me, it's the story of it, not just historically and how it was used in industry, but also the story for us personally as artists of what it takes to get it, because it's something that you earn with a lot of work, and you know, beyond the beauty of how it ages, beyond its strength for certain applications, I find a really cool story in iron.
Yeah, I mean, it got us to where we are today as a society, you know. Without the Industrial Revolution, you know, without Iron Bridge, you know, we wouldn't be anywhere near where we are.
I think that for me, it's historically and conceptually, I agree with Paige. Finally, we agree on something. It's the anti-bronze, right? Bronze is a traditional art material. It's coveted, it's valued. You know, it literally, you know, has value, but it's also just prized historically as this art material, where iron is so mundane, so abundant, it's overlooked, right? We drive over it every day, you know, passing over sewer caps, and we just take it for granted. So to be able to play with that subversively, I think is really interesting. But I think the biggest thing for me is the process, right? I'm a technician, I'm a process person, and I'm so connected now to the process and the community of making iron, that's really what it has become for me.
So just kind of going back to when Margie, you said we're talking about poking that you don't like, just FYI, Ian Skinner made a lot of poking emojis in the
Sounds about right.
comment.
Yeah.
So
Well done.
Kevin Vanek asked, what about the disappearance of coke?
Burn some more trees. Yeah, no, and that's actually a good question, because it brings up like a much more broad topic, is, you know, the scarcity of some of these materials. And, you know, as the earth starts having to, you know, worry about global warming and, you know, our carbon footprint, you know, how are we complicit in that? Does it matter? But yeah, it's getting harder to find iron, you know, especially in the South. We've already busted up all the radiators, you know, there just aren't any down here anymore. So we have to go, you know, to industry and see if we can get, you know, materials from them. And so it does become more difficult.
We'll do a cultural exchange. We're overflowing with radiators up here in New England, but I can't get my hands on coke. It's getting more and more difficult. I miss the days of just driving over to ABC Coke and saying, fill her up, you know? But that's not a thing anymore. We have to like order it by the super stack and pay for it and all that. It sucks, but radiators we got. So.
I'm kind of reminded between Margie and Paige, what they were saying, conversation I was having with someone, like, so Margie said she loves iron because it's not precious like bronze is. But at a point, some of the radiators that we're busting up are far more beautiful than what we're casting at sometimes. Yeah. You know, so I was talking with someone a while ago, you know, what's going to be maybe the next non-precious thing where, you know, we have that same feeling. I don't know.
Yeah, I'll go ahead and say it.
Right? See anymore?
A lot of radiators are works of art, and they're definitely better than some of the art they've produced.
Yeah.
So George Beasley gave you guys all an A+. And
Validation.
to follow that, Alexander Gelderman asked, does anyone have suggestions for archives and videos of Beasley's stick furnace run? And a few people on the chat said you could go to George's website, but do you guys have any other resources for that?
Yeah, there's a really good video of the performance we did in Latvia with one of the stick furnaces. And I'm not even going to try to tell you how to spell the Meethemov transfer at Ped Volley, but if you just Google, you know, like George Beasley you know, Latvia Performance. There's a good high quality video that was made of that one.
He's also a super gracious person. And
Yeah.
Like if you contact him, George, I did not give them your info. I don't know.
Can we scroll George's cell phone number across the screen right now?
No, but-
Actually, we need Judy's cell phone number.
Yeah.
Yeah.
No, but if you email him, he's just a wealth of knowledge, and he's more than willing to share. And I personally have seen a lot of the pictures. There's a lot of more crazy stick furnaces than I had the privilege of working with him on.
And the great thing about George is if you think you have an original idea, he'll tell you how he did it in 1974.
Or he'll assume that you were there, right? Even though I would have been like 12. So the other thing, you know, and to continue what James was saying, not only is George an amazingly gracious person, but the whole community is, right? So if there's anybody out there watching this that says, you know, like, man, I'd really love to reach out to Paige to talk more about furnaces and, you know, maybe pet our cats simultaneously, please, reach out to any of us. This is why we're here, because we like talking about this stuff and we like sharing information. So my experience certainly is that the community at large is really approachable and accessible.
Half the time my advice is don't do that. I did that and it went badly. So I speak from don't do what I just did.
We have, I actually really like this question. Miranda Kyle asks, and to throw iron or not to throw iron? And that's kind of a big thing, right? Like performance versus using it to make artwork. I think that some of our professors in the days have had various ideas about that. So if you guys want to chime in on that question. Aaron Cunningham said that Donnie King would tell you, y'all wasted my metal.
So I think that I want to make a distinction between performance and spectacle. Okay? If you're throwing iron around, Katie, stop. You're making me dizzy.
Oh, sorry.
God damn. All right.
You run through.
If you're just a little slower, I don't have my reading glasses on. If you're throwing iron around for the sake of throwing iron around, that's a waste of metal. If you are making performance art, if you have intent and you are using the material in its liquid state to convey meaning, that is art, and I can qualify that as legitimate. And that's a huge distinction that I don't think is talked about very often, right? I feel like 90% of what I see classified as iron performance is spectacle, and that I'm kind of over with, honestly. But true performance art, and I'm not the person that should make that distinction. It depends on the artist, obviously, and what they're meaning, what they're trying to get across. But you know, that there is a legitimate place to use iron in its liquid state to convey meaning beyond just putting on a good show.
Yeah, and if you go back to the word performance, I mean, just like in performance art, there has to be thought and idea behind it. And one of the things that I found is, you know, when it comes to performances, people take themselves so seriously, and you know, you can have humor behind it. You know, you don't have to just throw stuff to make the spectacle and act like it's a serious thing. It's not original, and you know, it just. Yeah, don't be afraid to have fun with it. You know, just because it's not big and flashy doesn't mean it's not, you know, relevant or useful. When I was invited to do a performance at the Georgia State Holiday for a few years, I decided to cast irons out of cast iron and use them to draw irons, you know, and it was just, I didn't want to, you know, have giant explosions because I couldn't bring anything new to that. So, you know, don't be afraid to change it up. You know, just, you don't have to throw iron, but if you want to, you know, cool.
Another question that was asked early on was asked by someone for another person, which is, what if I do not want, or what if I cannot do the math?
Get a calculator. No, but again, reach out to somebody. We're all here to help, you know. A lot of people have this stuff, you know, memorized or written down already, and it's just they're an email or phone call away.
Well, and Margie, I think Margie and I have really been talking about ways of archiving this, because at some point it's a lot of the stuff is word of mouth, and so I think we started, you know, it is getting archived, and so are the stories, but I think I don't know, I mean, doing more conferences and talking about this stuff is probably the best way. Now things are being archived on, you know, this is recorded, it will be archived on our website, so that's available to you.
I mean, the information is out there, right? If math isn't your particular skill set, that's fine. I will never be a professional basketball player, not within my, you know, physical skill set. Happy to do math for you. Or, you know, and Paige, like, you know, you had mentioned in a previous discussion, like you just made a chart of like, okay, if I'm making this size inside diameter, I'm going to go with this size well. It's going to tap this much metal. So, you know, all of the information exists. It's not hard to come by. Don't be shy. I mean, as a formerly shy person, I understand that it's hard to potentially reach out, which is why I can't say enough, you know, please reach out. We're happy to help.
And the more you keep doing it, the better you'll get at it, and the more you'll remember. But I would say starting out, take those books, copy them, put that chart in your studio, tape it to the wall, tape it to the back of your door, have that reference around. Like it's really valuable for yourself, but then also for others that are maybe helping you. To say, hey, you know, what size are we doing? It's on the chart. Look on the chart. You know, it's that way you don't have to reinvent it and go and find it.
But I think to Biz's earlier points too, you know, that chart doesn't do you any good until you potentially have a conversation and get some advice from people about what you might want and what might suit your needs best, right? Where again, you know, there's so many people out there that are willing to be a resource for that. Based on personal experience, they can make recommendations or, you know, extend some words of caution or
Yeah, and what we're talking about is not something that should be taken lightly as far as safety goes. Talk to people, get a feel for it. You know, don't just dive into iron with no advice. That's kind of a recipe for destruction. Read up, you know what kind of safety precautions you need.
Well, I have a question. I was wondering if you guys recorded your like the times that you added coke and the times that you added iron. And I've seen some people do that. Both schools that I went to, we used to do that, but then other places are, you know, I know it becomes intuitive at some point, like at SLOSS, it's very intuitive. They know when all that happens, but do you think that would be a benefit for beginners?
Yes.
Mm-hmm.
Yes, especially when you're, not only you are a beginner, but you are potentially interacting with a new furnace that is not a known entity, right? And it's a good way to train other beginners, right? So I know my furnace, I don't need to keep a charge chart anymore, but it is a good thing if I'm trying to train someone new on that furnace, or if I build a new furnace that I don't know exactly what its personality is going to be yet. That's why Little Bastard is called Little Bastard, right? So yes, pro charge chart, at least at the beginning for a while.
Yeah, and it was something I used to keep track of, like every charge and all the time, but you know, then like they both said, it becomes intuitive, and you know, the time that your furnace is taking to do something really will tell you how it runs. And if you read any of the older books, you know, like any of the C.W. Ammon books, they will straight up tell you, like, if you have a furnace this big and it's running at this pace, by the time you add the first, you know, charge of coke in when you're starting, you should have iron within, you know, 7 minutes. If you have it in 9, this is what's wrong. If you have it in 5, this is what's wrong. And so just reading some of that literature can really help you diagnose what's going on with the furnace. And to know that, you need to, pay attention to the time it takes to do stuff, the time, how long it takes you to burn in, how long it takes from first charge to first metal, between taps, things like that. Because that can diagnose the majority of your problems, just paying attention to that.
And the furnace tells you what it needs, is what Paige is saying, right? If you're paying attention. The students are always astounded when, I'll turn around from across the pour field and say it's time to charge. And they think that I'm a magician or, furnace whisperer or something, which, I mean, I kind of am. But no, I'm reading the flame. The flame just got really huge, right? You can see it. So getting to be able to read those signs will get you into that rhythm with, charging and tapping and all that kind of stuff. But it's nice at the beginning to have a written record that you can go back and even just to diagnose, right? Because if you're in the moment and especially if things are going wrong, you're not necessarily going to have time to diagnose in the moment.
Right. And we usually just write it all down on the furnace and take a picture after of times, because I am super curious about looking at little things that I did different on different pours, because I mean I figure I'm going to be learning the whole time till I die pouring iron. I'm going to be learning from each single time, so I like to keep a record just so I have some kind of facts I can go back and look at and see if I did anything different, because when you're running a furnace, like Margie said, you look at it, if it's hungry. You gotta feed it. But you might not think in the end, when I said it was hungry, was that 12 or 14 minutes? Whatever.
So I guess, I think this question is a pretty good one to, like, if everybody answered it, it'd be a good way to probably end the conversation. So Hanson Andy Bassey asked, what are your worst mistakes you've all made during your career?
Having him as a student. I'm joking. I assume that means in our iron casting career. So I'll go with that one. The worst thing that I ever did, honestly, was probably dropping the bot into the ladle at Sloss the first time we took our brand new furnace and ran it in front of everybody. Which is totally inconsequential in the grand scheme of things.
What about that gasket issue, Paige?
What gasket issue? I don't know what you're talking about. I never ruined an iron pour at Franconia during a residency by mixing up unmarked bags and laying in a bed. That's cold.
I think there are so many things. I mean, I've been pouring iron for, quite a long time now, and lots of little stories. But I would say the biggest thing is what I already explained when I was talking about the slaggers. Participating in that was potentially life-threatening. And so that was, again, tons of metal in a furnace that was about to split apart, with many people above it on aluminum scaffolding, with tons of iron about to go everywhere underneath it. So safety, I cannot preach safety enough. I mean, I guess I've been teaching so long that is the biggest thing, right? Is just making sure that is always the forefront of your decisions.
I'm trying to pick of all of the stupid things I've done.
Right, yeah.
I mean, it's really hard to, I have definitely gotten up under furnaces when I should not have. And the one time I was real close to getting up under a big one, I got my lesson learned on that one. I feel like a lot of times when I've been regretful is when I didn't speak up. When I know it's shocking now, but I was really quiet and really shy and I would go to other people's pours and I would see things, you know, potential safety issues or, you know, logistical issues. And I didn't feel like it was my place to say anything. And then something went wrong. And I felt awful that I didn't say something. I feel like I'm getting myself off the hook for all the stupid crap that I've pulled over the years. Standing on molds, you know, human mold weight is one of my favorites. I actually really enjoy that one. Yeah, I tend to do all the dumb stuff to have my students not do it.
Yeah, I would agree with Margie on a lot of the things she was saying. I have also learned, I'm not going to say which ones, of the mistakes that I'm willing to admit on a recorded record. The only one that really comes to mind that was fairly recent, when you're planning an iron pour, you look at charges, you look at making sure that, you know, your iron furnace is running right and is prepped. Yeah, if you run out of bot, the game's over. And we had a lot less bot than I thought. But I did find out that, you know, when you scrape that bot off and the non-burnt part falls on the ground, you can reconstitute that real quick in the middle of a pour. Mm-hmm. Yeah, look at all your materials.
And that actually goes back to what Stacy brought up. I kind of forgot about, but when we were at Franconia, you know, I was like, hey, yeah, I'll lay in the bed. That's fine. Pay attention to what you're doing, because somebody just handed me a bag and was like, here you go. And I didn't look, you know, and it's a different system than I'm used to. So if you're somewhere else, you know, pay attention to what you're doing. You know, not everything is going to be set up the way you normally do it. And then, you know, a couple 100 pounds of iron fall out the bottom of a furnace and you have to stop, and that's no good.
Never be too embarrassed to say, hey, what is this? Or, hey, I'm not familiar with this. Like, not worth it.
Katie, would you also like to answer that question?
Yeah, I mean, no particular thing, just lots of things. Lots of things. It's not doing it for a while and then returning and having to refresh yourself. Those things can happen. No, just I mess up all the time. I'm okay with it. It's cool. It's a learning experience always.
Riding around on a golf cart using an orange cone as a megaphone.
That's yeah, that's non-pouring things.
It was pouring adjacent.
Yeah.
Katie, all I gotta say is coke goes in the furnace.
Right. Yeah. I mean, if that's the worst thing that I've ever done is drop some coke, but that's definitely not. There's tons of stuff, of course. It's always a learning experience, and you're always going to mess up, and things are always ever changing too. So it is what it is. Work with what you got. Know what you have when you have it, and stick with her, because she'll do what you need her to do as long as you take care of her. But yeah.
I think mine was definitely setting many pigtails on fire and having to sport like an Edward Scissorhands haircut or baby bang.
Eyelashes. I hate when I get the eyelashes.
Those hairs.
Yeah. Yeah.
Well, on that note, I want to thank you guys all so much for sharing your expertise in this field. MSA really appreciates you giving your time for this panel, as well as everybody else watching. So thank you guys so much, and we'll see you guys next panel.
Thanks for having all of us.
Thank you very much.
Thank you.
Yay, you all!